All right, so we're going to take a look at types of samples and bias that can occur. And so when we talk about a sample, remember, you have your population, which is everybody that you want to get some data about. And then it makes more sense, though, that you would find a sample because you can't possibly talk to the whole population sometimes. And so you just need a sample. And so in a sample survey, we are studying a randomly selected small group in order to hopefully gain information about a larger group, the population. So if I could test the small group, then I could make some generalizations about everybody together. Now, when we do samples, there are some methods which are better than others. Sampling methods which tend to over or under represent a certain subgroup of the population are said to be biased. A biased sample is not representative of the population, right? It's not a good representation of the whole population because it might favor one group or it might not give any details about another group. So you have to be really careful to accurately represent each subgroup of your population. We want to avoid bias as much as possible. There is usually no way to fix a biased sample, and the results from such a sample are generally not useful or valid at all. So if you have bias when you pull your sample, there's really no way to fix it. You have to make sure that you're selecting your sample unbiased from the start in order to make sure your results are valid. In order to attempt to avoid biased samples, we use a randomized process to select our sample. Randomizing helps protect us against factors we know are in our data and also assists us in minimizing the effects of factors we may not even realize could affect our results. So sometimes you might be aware that, let's say, you are sampling a population and you want to make sure that you get samples from every gender, but you might not have even thought about how maybe the background of certain people in your population might also affect their answers to whatever it is that you're studying. And so there's the ones that you know could give bias, but the things that you might not have even thought of could still bias your results. And so that's why randomizing is one of the best ways to help you get a good sample. Randomization protects us from the influences of all the features of our population by ensuring that, on average, the sample mirrors the population. So we choose randomizing because we want the sample to mirror the general population. I basically want to look at my sample and it should look similar to what the population as a whole looks like. So let's go over some of the types of these sampling methods. And the first one is a simple random sample. A simple random sample is where every member of the population has an equal chance of being selected. So let's say that my population, I want to do a study on people in the United States of America, right? If I choose a simple random sample, that means that you, living here in Georgia, have an equal chance of being selected as somebody who lives out in California. Every member of the population has an equal chance at being selected. The next one is self-selected. And so in self-selected, this is where members volunteer to be a part of the study. Now, when people volunteer, that can often show some bias. So sometimes self-selected isn't always the preferred method. Another sampling method is convenience. In a convenience sample, you are selecting members that are easy to reach. So if I start to think about a study maybe at Dacula High School. So my population is all students at Dacula High School. If I were to conduct a convenience sample, I might just ask the students in my class. If I were to ask you guys my questions, that would be a convenient sample because it's easy for me to get in touch with you versus conducting a sample and having to choose students from all over the school. Again, you might see how this could be biased though, because just for one example, I teach mostly sophomores. So I'm not going to really get a good representation of all grade levels. And there could be some other unrepresented groups in there as well. Another sample type is systematic. In a systematic, a rule is assigned for selecting who you're going to sample. For example, a common rule might be like every third person. That would be your rule. So if I were going to stick with the Dacula High School example, let's say I go at the beginning of the day and I stand at the front door as students are entering the building to start the school day. I would then sample every third person that goes to walk in the door, and that would be a systematic sampling. The next two types of sampling often get confused, so it's really important that we understand the difference. A stratified sample is where I take the population, I divide it into groups, and then members are selected at random from each group. And I'm going to triple highlight each because this is a key difference between this and the next one. So let's give a stratified population or stratified sample example. Wow, that rhymes. Okay. Let's say our population is Dacula High School. I might divide the student body into groups based on grade level. So we might have a 9th grade group. I'm going to draw stratified over here. So I'm going to break everyone up into their grades, 9th, 10th, 11th, and 12th. For some reason, I always think about this example as if we are in the gym at a pep rally because you all sit with your grade levels. So it would be like you're all broken up into your grade levels, and I randomly select 5 people from each grade level. So I take 5 9th graders, 5 10th graders, 5 11th graders, and 5 12th graders. This is an example of a stratified sample because I've taken a little bit from each group. Versus a cluster sample. In a cluster sample, we do again start by dividing into groups. But then after I divide it into groups, this is where it gets different. A sample of the groups is randomly chosen and all members of chosen groups are sampled. Here's the key. All members of the chosen groups. So in that example where you're broken up by grade level, that would be like if I broke you up 9th, 10th, 11th, and 12th, and then I selected 11th grade, and I would sample everybody in 11th grade. That's not a super great example of cluster because that's one that we probably wouldn't actually use because, well, that's going to be very highly representative of 11th graders and have nobody from the other grades. So a better example for cluster, one that actually might give us a good representation of the school, is if I break everyone up in or by their homerooms. Right? So I'm going to break everyone up by their homeroom teachers, and there's a bunch in the school. And then I'm randomly going to select certain homerooms. So I might select Miss George's homeroom, Miss Foy's homeroom, Miss Watson's homeroom, and Mr. Wilson's homeroom. And if I select those 4 homerooms, I'm going to ask every student in their homeroom to be part of my sample. So I'm going to take all, let's say everyone has 20. I'm going to take all 20 from each of these homerooms. But I'm not going to look at anybody in any of the other homerooms. So I randomly select which homerooms, and then I ask every person in each of the homerooms.